Welcome back to an exciting day in Algebra 2 land. Today we are looking at absolute value applications. So this is where we look at those equations that we learned how to solve last time and where can we actually apply them in the real world. So a few examples of where that happens is anywhere where we can model a situation with tolerance, meaning there's a range of possible answers. So most often you will see this with dimensions for various things. So like a pipe fitting, for example, is 3 meters with 2 centimeters of range. That means either up or down, so greater or less than. Tire pressure, you want it to be 35 within 2 psi, so that is either up or down. And then if you're like 3D printing something, this is a possible range for your dimensions. So, and again, the plus and minus means that it can be greater or less than your value by that amount. So some quick information here. The first value in each of these is called our midpoint. And the second value is our maximum distance, how far away we can be. So these are our steps to solving these equations. If you don't already know the midpoint or the maximum distance, that is how you calculate them. But then this is your equation. X minus your midpoint equals the maximum distance. Then you can solve your two solutions, and you need to check for their reasonableness in the context of your problem. So if I move on to example 1 here, the listed weight for a loaf of bread is 400 grams. And the actual weight is allowed to vary by up to 25 grams. So this 400 is my midpoint, and this 25 grams is my max distance. So I don't need to calculate either of those because I already know them. So my equation is going to be the absolute value of x minus my midpoint, which is 400, equals 25, my max distance. And now I can use that. I've written the equation, and I'm going to solve it to find the minimum and maximum value for the weight of bread. So setting up my two equations, x minus 400 equals 25, or x minus 400 equals negative 25. So I'm just going to add 400 for both of those. And x equals 425, or x equals 375. So what that means is I have now found the maximum weight and the minimum weight for the loaf of bread in this particular store. So the weight of the bread is able to fluctuate between those two. So the bread should be between 375 and 425 grams. So if the store samples the weights of several loaves of bread and these were what we found, which ones would we reject? Well, we want to make sure that all of these loaves of bread are between 375 and 425. So if they fall in that range, then they are okay. If they are outside of that range, it will not be. 405 is greater than 375 but less than 425, so it's okay. Same for 409, greater than 375 but less than 425. 378, greater than 375, but less than 425. 360 is less than 375, so we have to reject that bread. 425 is greater than 375, but less than 425, so he can stay. 374, again, outside of my range because it's less than 375. And then 402 is greater than 375, but less than 425, so that one gets to stay. So we are going to reject the one that is 360 grams, and the one that is 374 grams. Okay, we just have one more example to look at here. A national TV variety show televises performances each summer. The producers require the acts to be between 1.5 and 2 minutes long. Write the equation to represent the minimum and the maximum. Well, what we are given here is the minimum and the maximum values. So what we need to calculate in order to write this equation, remember the absolute value of x minus the midpoint is going to equal the maximum distance. We need to figure out what those values are. So first, to find the midpoint, if you circle back up to where that definition was, it is the max plus the min divided by 2. So my max is 2, my min is 1.5. That becomes 3.5 divided by 2. Which is 1.75. So there's my midpoint. Now I just need to find my maximum. my max distance, excuse me, because that's different than the maximum, is the max minus the min divided by 2. So 2 minus 1.5 divided by 2, that is 0.5 divided by 2, which is 0.25. So I can now plug those in here. My midpoint is 1.75, and my max distance is 0.25. So basically what we did for this one is we worked backwards from our two solutions to find the equation, where on the first one we found the two solutions using the midpoint and the distance, max distance. Okay, that's all I got for you today. Your homework is going to be a short worksheet. I hope this helps.